jaws of life were first used in 1963 to free race car drivers from car crashes. It was so big it had to be suspended from the back of a pickup truck. Today it weighs as little as 33 pounds and is small enough for one person to operate. It can free an accident victim from a car in minutes. In an emergency situation, timing is everything. A rescue tool has to pry open a vehicle as easily as a tin can or cut through solid steel like butter, because a few seconds can make all the difference. What gives the cutting blades and the spreading arms their power is hydraulic fluid. The jaws of life begin with a milling machine that shapes the spreader arms from a bar of solid aircraft-grade aluminum. The spreader arms then get a protective coating. A lathe now makes the cap that fits on the end of the tool. A high-speed carbide tip shapes the solid aluminum into a finished end cap that is then drilled and treated to a coat of rust-resistant protection. Arms that both cut and spread are made from tool steel. A surface grinder ensures that the two arms are perfectly flat. A worker installs a seal that prevents the hydraulic fluid from leaking out of the cylinder. He lubricates a piston with hydraulic fluid so it slides into the cylinder without damaging the interior. Then he taps it in so it will connect with a link assembly. He attaches a link assembly to the piston and secures it in place. The link assembly relays power to the cutting blades or spreader arms. He then attaches an assembled end cap to the cylinder and bolts it in place. He connects the two hoses that lead to the tool's hydraulic cylinder. He puts on a hand grip that protects the hoses and makes it easier to work the thumb wheel. He tightens the bolts and completes the control valve. He then attaches the front handle that allows the operator to hold the tool safely. This protective guard will keep all the moving components away from a rescuer's hands. Then he aligns the holes in the blades to the tool and inserts a steel pivot pin. He puts on a lock nut, and as with all fasteners on the rescue tool, he tightens it to a precise engineering specification. After mounting the blades, he secures them to the link assembly with a steel alloy pin and a snap ring. Then he folds the protective guard back and finishes assembling the tool. A worker then tests the tool, which has been filled with fire-resistant hydraulic fluid. The fixture he uses is designed to measure the pressure at the strongest point in the cutting. The tool passes the pressure test. Whether it's a rescue tool that cuts through metal or pries it open, emergency response teams arriving on an accident scene will have what it takes to help save lives.